1.5 notes. Today's notes are over special angles. So last time we just talked about how to construct an angle, what it was made of. Now we're going to talk about some special names of angles. And the first one is called complementary. So two angles are complementary. If the sum of their measures is 90 degrees. So remember, sum means if you add it together, they're 90 degrees. If you look at this picture over here, okay, there are two angles, angle 1 and angle 2, and then there's also a larger angle and the big one. We could call that angle 3. These two angles, if you were to add them together, they equal 90 degrees. And we know that because of that box that's around the vertex. Remember, that box around the vertex is proof that that angle is exactly 90 degrees. If that box isn't there, then you can never assume that that is not a 90-degree angle. The other type of angles we're going to talk about are supplementary. So two angles are supplementary if, this should say if the sum of their measures is 180 degrees. It is important that you can distinguish between the two, complementary 90 degrees, supplementary 180. There's a bunch of different little tricks for remembering this. The one I use the most is called the more p's, the more degrees. So you see the word complementary has one letter P, so it gets 90 degrees. Supplementary has two p's, so it's 180 degrees. So the more p's, the more degrees. Also, another little trick is if you look at the P, it kind of looks like a backwards 9. So supplementary here has one P, so if the P stood for 90 degrees, this is 90 and 90, which is 180. All right, so this is a picture of supplementary. So two angles, 5 and 6 right here, that would add up to 180 degrees. So 180 degrees is going to be a straight line. A straight angle will also measure 180 degrees. Now, the difference between these two pictures are what we call adjacent and non-adjacent. So complementary and supplementary angles can be adjacent or non-adjacent. And what the difference is adjacent means right next to, it's touching, like your neighbor that you sit next to in class. You are adjacent to them. You're basically, you're sharing the side in between you. So that's basically the definition of adjacent angles. Adjacent angles are two angles that share a common vertex and a common side. Because remember what an angle is made up of. So hopefully you can remember that from the previous notes. An angle is two rays that share a common vertex. And when we talk about the rays, these are referred to as sides. This is the vertex, okay? So in these pictures over here, we're going to talk about the difference so you can see adjacent and non-adjacent. These ones here, these are both complementary angles because they both are going to add up to 90 degrees. And I'm going to put some measurements in here. I'm going to say this one is 20 degrees and this one is 70 degrees. So complementary. Now, what else is different between these two is that these are adjacent and this set is non-adjacent, and we abbreviate that sometimes with just ADJ. So adjacent and non-adjacent angles, do you see in this first one, these are adjacent. They are sharing this side, and they're sharing that vertex right there. So sharing a side, sharing a vertex. Non-adjacent angles, they're not sharing a side. They're two separate ones. They're not touching. These can all also be considered complementary. So complementary angles do not have to be adjacent. They can be either or. Same thing with these supplementary angles here. So these are supplementary angles. And make sure you're drawing these pictures of the adjacent and non-adjacent angles both sets, the complementary and the supplementary. Here in the 5-6 diagram, these are going to be the adjacent angles because as you can see, they are sharing this vertex right there and sharing this side. Now in this 7-8 pair, let's say this one is 130 degrees and this one is 50 degrees. We can say that those are also supplementary because if we were to add 130 and 50, we'd get 180, but these are non-adjacent because they're not sharing any sides or angles, they're not touching. So how you're going to see this is an example 2. Find the measures of a complement and a supplement. In A, given that angle 1 right here is a complement of 2, then measure of angle 1 is 68 degrees, find the measure of angle 2. So when it says it's a complement, complement is just a little short for complementary. So these two angles together need to add up to 90 degrees. So they're asking us, well then what is the measure of angle 2? All you have to do is take 90 minus 68, and that should give you 22 degrees. So that's going to be the measure of angle 2. So all you have to do is subtract out what's given. Same thing in this scenario, given that angle 3 is a supplement of 4, so 3 and 4 are supplementary, so that means together, and we know because they're sharing this line, these angles right here measure 180 degrees. If we were to get out that protractor and measure it, it would be 180 degrees. So how much is 3? Well, 56 is already taken up by angle 4, so 180 minus 56. And we're going to get 124 degrees for the measure of angle 3. Now that's just with numbers and integers in there. We're also going to start seeing it with variables where, remember I keep talking about we're going to have to set up equations where we're adding things up to 90, we add things up to 180. So look forward to that. Now we also have a special name for two adjacent angles. So two adjacent angles are a linear pair if their non-common sides are opposite rays, and just let's write all this down and think about it and then we'll draw it. The angles in a linear pair are supplementary. So let's think about that. Two adjacent angles, they form a linear pair if their non-common sides are opposite rays. So if we think, all right, let's draw two opposite rays. All right, so there would be two opposite rays. Because remember, opposite rays have to be collinear. Now, if I wanted to make some angles out of that, I would then extend out another ray, and then I would create angles in here. This would be angle A, and this could be angle B. So we'll read the definition again and look at the picture. It says two adjacent angles. So yes, these guys are adjacent because they share that vertex, they share the side. If their non-common sides are opposite rays, so this side is just for A, and this side is just for B. So yes, their non-common sides are forming opposite rays. So we call this type of angle relationship a linear pair. And always linear pairs are supplementary. So always, 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 if you have a linear pair, they are going to add up to 180 degrees. Now what you have to be careful about is the word pair. There can only be two angles that are making up the linear pair. Like you cannot have three angles that make up the linear pair. So if we had this, and this, and let's see, that would be our vertex, and if we had some angles in here, 1, 2, and 3, all right, we could say that these guys, this is not a linear pair because there's three angles. 3 is not a pair, 2 is a pair. Now another important one is vertical angles, and these two concepts, a linear pair and vertical angles, we will talk about all year long. So you have to make sure you understand them. So the next one is two angles are vertical angles if their sides form two pairs of opposite rays. So here we go again. Their sides form two pairs of opposite rays. So if we draw one opposite ray here, and we can draw another opposite ray here, So now we have two pairs of opposite rays. What happens is now that there's angles formed in here. This is angle 1, angle 2, angle 3, and angle 4. Well, vertical angles are opposite from one another. So if you look at the picture right here, 1 and 3, so what happens is that vertical angles are going to share a vertex, but not a side. Share a vertex, not a side. So 1 and 3 share the vertex, but 1 and 3 don't have any sides in common. So 1 and 3 are vertical angles. And then also you can go the other way, 2 and 4 are also vertical angles because they share that vertex right there. Now, what's special about vertical angles is that they are congruent. So remember, anytime we have angles that are congruent, that means that they have equal measures. So really two important things to take away from this. The linear pair is always supplementary. So linear pairs always add up to 180 all year long. The next is the vertical angles are always congruent. So 2 and 4, whatever their measure is, it's exactly the same. 1 and 3, it's exactly the same. Then what you need to also look at in this diagram here is not only do we have vertical angles, we also have linear pair. And so you have to find that and say, okay, well, I know linear pair, they must form opposite rays and they must share a side and a vertex. So if you look right here, 1 and 2 are a linear pair. You can keep going around the diagram and find another linear pair. 2 and 3 form a linear pair, and you keep going around the circle. 3 and 4 make a linear pair, and then the last one you have there is that 4 and 1 right here can form a linear pair. So within this diagram, we have adjacent angles, we have linear pairs, and we have vertical angles. In example 4, and this is kind of helps you see in another diagram, in example 4, identify angle pairs. Identify all of the linear pairs and all of the vertical angles in the figure. So a linear pair has to be 180 degrees, and there can only be two of them. So let's just start, and we'll look at angle 1 and angle 2 right here. Well, they can't be a linear pair because they're not forming a straight line. 2 and 3, they still don't form a straight line. 3 and 5, not a straight line. 5 and 4, do you see 5 and 4 right there? They are sitting right here. And if you were to measure 5 and 4, they would equal 180. So linear pair, angle 4 and angle 5. Then let's see what else. If we keep going around, we can say, okay, look at 4 and 1. Yes, angle 4 and angle 1 are also a linear pair. Now it also asks us to find any vertical angles. So vertical angles have to be exactly opposite one another, and they have to share a vertex and not share any sides in common. So if we just start at angle 1 here and say, okay, if I go straight opposite from it, across from it, through the vertex, is there another angle that matches it exactly? Yes, there is. All right, there's angle 5. So vertical angles are angle 1 and, 1 and angle 5. Let's see if we can find any other ones. If I go to 2, is there anything directly opposite from it that is the same exact size? 2 and 4, 4 is a lot bigger than 2. Do you see how 2 looks like it's a right angle? And 4 is definitely obtuse, so those do not match. 3 and 4 don't match. Okay, so 1 and 5 is our only pair of vertical angles. In example 5, you'll see what I'm talking about now. Look what happens. We get x's, our favorite. Two angles form a linear pair. So they're telling you right here. So vocabulary, linear pair. You know, because I just told you up here, and you've got to have this memorized, is that linear pairs are supplementary. So they're supplementary, which means they're 180 degrees. This one says two angles form a linear pair. The measure of one angle is 5 times bigger than the measure of the other. Find the measure of each angle. So that word find is there. So we're used to now, if it says the word find, we know, okay, I have to make an equation from all of this. I know a linear pair has 2 angles in it. Okay, so that's 2 blanks. I know linear pairs are supplementary, which that word means 180 degrees. One angle that's sitting over here has a 5x in it. The other angle has an x in it. Now, oh my gosh, we can solve that equation. So you combine these like terms, so that gives you 6x equals 180. Divide by 6, divide by 6. So your x is going to be 30. Now find the measure of each angle. Remember, x is a variable, it's not a measurement. So to find the actual measurements, you have to take this and plug it back in to find the actual measurement. So one angle, if you go 30 times 5 is 150 degrees. Then the other angle, if you plug 30 back in for x, 30 degrees. Now remember, the end result is that you have a linear pair that are supplementary. So check your answers here. When you plug everything back in, your total should still be 180. If it's not, then you've done something wrong over here when you solved. So go back and check it, and then plug it back in.